8th graders. All right, here is the first lesson on L2-1, and it's on factors. So your first keyword here is divisible. A number is divisible by a second number if the number can be divided by the second number with a remainder of 0. In other words, it's like the divisor. When we talk about divisible, the divisor is the number something's being divided by, and if it works out equally, then it is divisible by that number. So here we go. We have this nifty little chart in your books on the divisibility tests that you can use. So these are great little tricks that you can use to figure out right away if a number is divisible by that. And if you so desire, you can make a foldable like this for your own notebook to help you remember them. The process might help you. So a number is divisible by 2 if the last number is even. So an example, 628. The last number is even, so it's divisible by 2. A number is divisible by 3 if the sum of the digits is divisible by 3. So our example, 321. 3 plus 2 plus 1 is 6. 6 divided by 3 equals 2. It goes in even. So 321 is divisible by 3. That's a really fun trick for really big numbers. A number is divisible by 4 if the last two digits are divisible by 4. So that's helpful for really big numbers. For example, 1,932. Take the last two digits, 32. 32 divided by 4 equals 8. So yes, 1,932 is divisible by 4. Okay, 5, you guys know that one. If it ends in a 0 or a 5. 6, if it is even and the sum of the digits is divisible by 3. So basically same as if it's divisible by 3, but if it's also even, then you know that it's divisible by 6. Example, 936 is even, and 9 plus 3 plus 6 is 18, and 18 divided by 3 is 6. For 8, number is divisible by 8 if the last three digits are divisible by 8. So 14,248. 248 divided by 8 is 31, so it's divisible by 8. Okay, then my last two rules, it's divisible by 9. If the sum of its digits is divisible by 9, so that's similar to the rule with 3 and 6. So 7 plus 2 plus 3 plus 6 is 18. 18 divided by 9 is 2. So 7,236 is divisible by 9. And 10 if it ends in a 0. You guys already know that one. So there you go. Those are the divisibility tricks. Now, moving on from there, divisibility tricks are helpful when you're figuring out whether a number is prime or composite. So here's the definitions of these words. A number is prime if it can be divided evenly only by itself and 1. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31 are all prime numbers. Honestly, the best thing you can do is memorize this list of the smaller prime numbers. If you have them memorized, then you'll know right away that they have no other factors. Composite numbers are everything else. A composite number can be divided evenly by numbers other than 1 in itself. So 4 can also be divided by 2. 6 can also be divided by 2 and 3. 9 can also be divided by 3. 15 can also be divided by 5. You get the point. And then finally, neither. The numbers 0 and 1 are neither prime nor composite. Fractions are neither. And negative numbers are neither prime or composite. Okay? So now that we know our prime and composite numbers, we can find our prime factorization. We have two methods for finding prime factorization. So the first one, there are two methods to get the prime factorization of a number. The first one is using a factor tree, and the second one is the birthday cake method. This is a factor tree. You start with your number up here, 48. You draw two little lines, and then you write any two factors that equal 48. So I picked 6 times 8. Now, neither of those are prime. They have other factors, so we're not going to circle them. Then from 6, I draw 2 lines, and 2 times 3 equals 6. and 2 and 3 are prime numbers, so I'm going to circle them. For 8, I have 2 times 4. 2 is a prime number, so I'll circle it. 4 is not, so I won't. And then I draw out lines from 4. 2 times 2 is 4, and I circle those. Then down here, I write out all the numbers I circled, and I put them in order from smallest to biggest. Actually, sometimes I've seen it written from biggest to smallest too, but they should be in order. So 2 times 2 times 2 times 2 times 3. And then I can count how many 2's I have. 1, 2, 3, 4, and just write it as 2 to the 4th times 3. You're finished when all the numbers are prime, and make sure that you circle all prime factors. There's another method you can use for this, which is kind of fun. For the birthday cake method, it looks like a birthday cake, so the bottom layer, you're going to write your starting number. Then you do a little division sign, and you pick a prime number, that's the key here, that will divide evenly into the bottom layer. So 2, 3, 5, 7. So I'll pick one of those numbers, I divide it out, and then I keep doing the same thing on the way up. All the numbers on the outside are prime. Repeat until you end up with a 1 on top of your cake. This is the candle of your birthday cake. Okay, let's look at what it looks like. So for the prime factorization of 24, here's our traditional factor tree. Now over here's the birthday cake method. I started with 24 on the bottom. I drew my division sign and I picked a prime number that goes into 24. So 2 goes into 24 12 times. Then I thought of another number that goes into 12 that's prime. 2 goes into 12 6 times. 2 goes into 6 3 times. 3 goes into 3 1 time, and my 1 becomes my birthday cake candle. So then I look at all these numbers. 2 times 2 times 2 times 3, or 2/3 times 3. Here's another example for 72. So over here, 72, I factored it out in my factor tree. Here's my birthday cake. 2 goes into 72 36 times. 2 goes into 36 18 times. 2 goes into 18 9 times. 3 goes into 9 3 times. 3 goes into 3 1 time. I have my birthday candle. Add those up. 2 times 2 times 2 times 3 times 3, or 2/3 times 3 squared. This is also in this lesson. It talks about you finding the greatest common factor by listing. So we're going to quickly talk about least common multiple and greatest common factor. So the least common multiple is we are going to just list our numbers in a row right here, and we're going to write out all the multiples. So least common multiple of 6, 8, and 4. I wrote 4, 6, 8, and I started listing multiples of 4. 4, 8, 12, 16, 20, 24, 28. I did the same thing for 6. I did the same thing for 8. And as soon as I found the same number in all 3 lines, I know that that is my least common multiple. Greatest common factor is I'm going to find factors instead of multiples. So find the prime factorization of the numbers, circle all they have in common, and then multiply those circled. So, for example, the greatest common factor of 24 and 36. So I did my factor trees over here to find all of my prime factorizations. I've got it all the way down, and then I wrote them in order. 2 times 2 times 2 times 3 for 24. And over here for 36, I have 2 times 2 times 3 times 3. And then I circled all the ones they have in common. I paired them up. And then I multiplied what was paired. So 2 times 2 times 3, or 12. 12 is our greatest common factor. The other way you could find all the greatest common factor is to list out all the factors. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And then I could do that for both numbers, and then I could circle the biggest one that they both had in common. So either way is correct. That's how you find the greatest common factor.